Question number 3, a polygon of constraints is shown in the graph below. The rule of the optimizing function is p is equal to 20x plus 10y, and the objective is to maximize. Identify the system of inequalities whose solution set is represented graphically. I'm going to start with this point. My b value is 17, and my slope is, we are moving over 1, 2, 3, 4, 5, 6, 7, 8, and then down 1, 2, 3, 4. Negative 4 over 8. Which is negative a half. Y is equal to negative a half x plus 17. And we are shading below this, and it's a solid, so y is less than or equal to negative 1/2 x plus 17. The inequality for the first one. For this one down here, my b is 12, my slope is, we start here at e, we end here at f, we move over 5 and down 7, 8. We move down 8. Negative 8 over 5 is our slope. Because it is a solid line, and because we're shading above, it's y is greater than or equal to negative 8 over 5x plus our b value, 12. There's our inequality for this line. For this one, this dotted line, our b value is 10. Our slope is, delta x is 5, delta y is 1, 1/5. Y is equal to 1/5 x plus 10. Because it's dotted, it's going to be less than or greater than, and because we're shading below, it's less than. Y is less than 1/5 x plus 10. This one down here, the c value is 3. The slope, once again, is going to be 1/5. Our delta x is 5, our delta y is 1, so 1 over 5. It's solid, and we're shading above, so it's greater than. Y is greater than 1/5 x plus 3. Finally, this line, this vertical line, is going to be x is equal to 14. Because it's dotted, it's going to be less than or greater than. Because we're shading to the left, it's going to be less than, because all the x values that are less than 14 are found on this side. X is less than 14. Find the point or points whose coordinates generate the function's optimal value. If I find each of these vertices, then plug it into our optimizing function. You can do it that way. I'm going to use a scanning line. I'm going to start off with my optimizing function, optimizing formula. I need to get all of my vertices. All right, so if I'm going to call this my point A, it looks like 10 point something and 1 point something. I just don't know what those point somethings are. 1 point something and 10 point something. But I have to figure out what these are. This line is y is equal to 1/5 x plus 10, and this line is y is equal to negative 8/5 x plus 12. I'm going to equate those. I'm going to say negative 8/5 x plus 12 is equal to 1/5 x plus 10. To get rid of the 5s, I'm going to multiply each term by 5. So the common denominator is 5. Multiply this by 5, and I'm left with negative 8. When I multiply the 12 by 5, I get 60. I multiply this fraction by 5, I get 1. When I multiply the 10 by 5, I get 50. We have negative 8x plus 60 is equal to x plus 50. I want to get rid of this negative 8x. I'm going to add 8x to both sides. We end up getting 60 is equal to 9x plus 50. I want to get rid of the 50, so I subtract 50 from both sides, and that gives me 10 is equal to 9x. To get the x all alone, I'm going to divide both sides by 9. That gives me 10/9, or 1.1 repeating. 10 divided by 9 is 1.1111111. And then I can feed that back into either of these two equations. If I feed it back into this one, y is equal to 1/5 of the x value, 1/5 times 1.1 repeating, plus 10. 10 divided by 9 and get your 1.1 repeating. Or you can just say 1/5, 1 divided by 5 times 1.1111. Just put a whole bunch of ones until you get tired of putting them in. Plus 10 is equal to 10.22 repeating, so 10.2 repeating. That's our vertex. I will draw the vertex right there. This vertex, we can read it right off the graph. It is 10, 12. And this one is 14, 10. And this one is 14. This one we have to calculate as well. We have the line x equals 14, and we have the line y is equal to 1/5 x plus 3. I'm going to replace this x value with 14. Y is equal to 1/5 x, the 14, plus 3, because we know at this point where they meet, the x value is 14. 1/5 times 14 plus 3. 1 divided by 5 times 14, which is the same as saying 14 divided by 5, plus 3 is equal to 5.8. When the x is 14, we get 5.8. We have 14, 5.8. And this point we can read right off the graph is 5,4. And we're looking at 10x plus 10y is equal to p. Well, let's look at our scanning line. I've just switched to the p on the other side so I can get my y alone. Subtract 20x from both sides, so you have 10y is equal to negative 20x plus p. Divide both sides by 10. That gives you y is equal to negative 2x plus p divided by 10 is just some b value, so I'm just going to write b. I just can pick a b, so if I picked, if I picked 12 as a b value, and my slope is negative 2, so I'm going to go over 1 and down 2 like that. So it's going to pass through, like if it started at the E, it would pass right through this point right here. So I get a nice line that looks like that. If I move that over, it's going to go through this point, my A point. So this is going to be either a maximum or a minimum. If it went through the F, it would go through the interior. The same with this point here, it would go through the interior. If it went through this point, now it'd be fine. Okay, so this is going to be our maximum or our minimum. If it went through D, it would go through the interior as well. Really, we just have to concern ourselves with A and C. In any case, here's my table of values. My A point is 1.1 and 10.2 repeating, 1.1 repeating and 10.2 repeating, and the profit we get by that is 20 times 1.1 repeating and 10 times 10.2 repeating, and that gives us 124.4 repeating. For 1012, we end up getting $320. For 1410, we get $380. For 14 5.8, we get $338. And for point E 54, we get $140. It's either A or C, and we're looking to minimize which is the smallest, A or C. Well, A is smaller than C. Okay, so A is our minimum. Problem with A is it's not part of our feasible region. It's on a dotted line, so it can't be a solution. I'm just going to move over it just a little tiny bit. I'm going to pick a new point. I'm going to call it point F. So instead of 1.1, I'm going to go like to 1.2. And instead of going all the way up to 10.2 repeating, just 10.2. So it's going to be inside our feasible region, but just inside. Just going to look at 1.2 and 10.2. If I feed that in, call it F 1.2 and 10.2, and do 1.2 times 20, plus 10.2 times 10, that's going to give us 126. Notice it's less than B and C and D and E. A would be our minimum, but it's not within the feasible region, so we just pick something slightly more into the feasible region, like F. And that's it for question number 3. Have a good day.